Okay, let's look at 2005 Form B Problem 2. In the introduction, it says that a water tank at Camp Newton's holds 1,200 gallons of water at time t equals 0. During the time interval from 0 to 18 hours, water is pumped into the tank at the rate given by W of t in gallons per hour. During the same time interval, water is removed from that tank at a rate given by R of t in gallons per hour. Before I get started on reading part A, one thing I like to do is just make sure that I'm understanding what the given equations are for. So for example, that W of t is a rate equation. So it's already, a derivative of the amount of water that's coming in, for example. So this is the rate at which water enters the tank. And that R of t is also a rate at which water exits the tank. And this is up to you if you think that that is a good idea for you to do. Also, I decided when I first worked this problem out, I decided part of the way through that for explaining purposes, I decided that I'd like to introduce a function called v of t. And I'm going to let v of t be the volume or the amount of water that is actually in the tank at any time t. And if I decide that that's my function for the amount of water in the tank, then I could go back up to the beginning, that first sentence, and say that if the tank originally at time equals 0 had 1,200 gallons of water in it, that I could say that that means V of 0 is 1,200. So it's nice to have some notation for the initial condition. Okay, now moving on to part A, they're asking, is the amount of water in the tank increasing at time t equals 15? Why or why not? What I decided to do to figure this out is compare the rate at which water is entering the tank to the rate at which water is exiting the tank. If it's entering the water faster, if water is entering the tank faster, then I would say the amount of water is increasing. So I simply plugged 15 into each of the functions. And I think we all know that there are lots of ways to do that. So here's one way. And for this problem, it could be a time saver kind of in the long run type thing. So I entered WT in as Y1. Hopefully correctly. And I'm going to enter R of t in as Y2. And again, hopefully correctly. I'm going to choose a window of 0 to 18 so that I don't see unnecessary information. And then I really liked zoom fit for choosing the Y values. Oh, and it doesn't like it. What doesn't it like? Oh, it doesn't like that I used a comma there. That makes sense. I'm going to use an open parenthesis instead. Let's see if that makes sense. Okay, we're gonna have to do something about this window. I think it chose the window for me based on my typo. Let's try this again. Nope. Yep. Okay. Okay, so here's Y1. And here's Y2. Okay, and not exactly a time saver. However, now that I've graphed them, option 1 value, if I type in 15, it will first plug it into Y1, which it tells you at the top. So according to this. The rate at which water is entering the tank is 131 gallons per hour. And then if you push the cursor up or down, it'll plug the same number, 15, into Y2. It looks like I'm getting 252.872. Okay, so if I look at that, it looks like the rate at which water is exiting the tank is greater than the rate at which water is entering the tank. So I would say that the amount of water in the tank is decreasing. At time t equals 15. And as for why or why not, this actually over here to the left could explain. If you are feeling like you need to explain a little bit more, you could just say because R of 15 is greater than W of 15. And there you go. That's it for part A. For part B, it says to the nearest whole number, how many gallons of water are in the tank at time t equals 15. So that means that I want to know what the volume at 18 is. So let's think about what we have, we have the rate at which water enters the tank and the rate at which water exits the tank. So if I take the rate at which water enters the tank and subtract the rate at which water exits the tank, then what am I getting? I claim that I'm getting the change in the volume of water in the tank with respect to time. And you would not have to use this notation with V like I am, as long as we end up essentially doing the same thing. And my cats are fighting here on the counter. But anyway. Okay, so what was I doing? Okay, so let's go ahead and see, well, what would we do to get volume if we have dV/dt? Well, we could integrate it. So essentially, I would do the integral. I would do 0 to 18 of dV/dt with respect to time. And since dV/dt is W of t minus R of t, you certainly could have written that in as your integrand instead. I like writing it like this because it helps me to see that I would get the volume when t is 18, take away the volume when t is 0, and that was given right there as 1200. So let's make our calculator do this. Since dV/dt is Wt minus R of t, what I would do is go to Y3 and do variables, Y variables, insert Y1, and then go ahead and subtract Y2. And so Y3 is Wt minus R of t. So now, let's see, math, integration. My calculator is really old, so you could probably ignore this part as to how I enter that in. But yeah, on the AP exam, if your calculator dies and you need to borrow mine, this is how you do integrals. Integrand, variable that you're integrating with respect to, lower bound, upper bound. Anyway, they said to round your answer to the nearest whole number, so I'm just going to go ahead and write 110 for that. And then I'm trying to find the volume of water in the tank when t is 18, and they gave me V of 0 as 1200. So all I'd have to do is add the 1200 over, and I would have the volume that they're asking me for. So, and then they'd really like units of measure on this. So even if you don't write a sentence for this to answer it, you should at least put the units of measure on it. And that's it for part B. Now for part C, it says at what time t from 0 to 18 is the amount of water in the tank at an absolute minimum. Show the work that leads to your conclusion. So you're going to see me for part C doing typical work for finding an absolute minimum or absolute maximum where you consider all critical numbers that are necessary. So that would be endpoints, since absolute minimums and maximums can happen at endpoints. And then that could also be either all the critical numbers, places where your derivative is 0 or undefined, or it could just be certain critical numbers, like the kind that would result in a relative minimum. So for this problem, what I'm going to do is just kind of make it clear to myself, what is it I want to do? It looks like I want to minimize V of t, essentially. So, so let's look at critical numbers. So at least critical numbers to consider. That's not how you spell consider. Consider. Let's include endpoints. So that would be t being 0 and 18. And then let's also look at t values where, and so we're trying to maximize this amount function or volume function. So we'd be looking for when its derivative. And if we're looking for a minimum, we're looking for when the derivative would change from negative to positive. Okay, so how can we figure that out? So we can go to your calculator, and I would unselect y1 and y2 because I really just want to look at what y3 does, since that's my dv/dt function. And then we're going to probably change your window. I like changing my window so that it's about as big as the old window was, but it has some negatives and some positives. So I don't know, maybe we could just go from like negative 300 to 298. I don't know. That's probably bigger than I need, but okay. So this is the graph of dv/dt, and I'm looking for it, or its y coordinates, to change from negative to positive. So for me, the only place where that would happen would be at this number right here. So the function went from negative to positive there. So let's use calculate. Let's do the 0 feature here. We're going to move a little bit to the left, a little bit to the right, and have it give us that value. Okay, so that critical number would be 6.495-ish. Okay. Now, the typical move for finding an absolute minimum would be where you actually find the values of the function at any critical numbers that you're considering. So for me, that would be 0, 18, and this approximately 6.495 number. So I'm going to compare the volume at 0, which was given as 1200, to the volume at time t equals 18, which we just found in part B. And then to get the volume at this time over here, we could just use a similar move to what we did here, just put the 6.495 as the upper bound. So knowing that that would be the volume at that time, take away the volume at 0, which is 1200. So back to your calculator, going to the home screen and just doing an integral again. Okay, and I got negative 674.75, 8-ish, which would be the value on this side over here for the integral. So we'll just add the 1200 over to the other side. Okay, so now I have this volume amount here. So I would say the volume at is about 525. So the question wanted to know at what time t is the amount of the water in the tank at an absolute minimum, and I would say this is the absolute minimum. And so let's go ahead and make a conclusion here. So I'll use their wording right back at them. The amount of water in the tank is at an absolute minimum at t approximately 6.495 hours. There we go. I feel like this needs wheels. Okay. Let's see, part D. For t greater than 18, no water is pumped into the tank, but water continues to be removed at rate r of t until the tank becomes empty. Let k be the time at which the tank becomes empty. Write, but do not solve, an equation involving an integral expression that can be used to find the value of k. All right, so for this, let's think about, well, how much water is there at time in the tank at time t equals 18? And we'd already found that. So you basically need to drain that much water out. So, so how could we figure out how much water is, set something equal to this that would equal how much water is drained out of the tank? So it makes sense to me that we would need to take the integral of the rate at which water exits the tank. So let's do an integral of r of t dt. And then what kind of bounds would make sense? Well, you would start draining the tank at time t equals 18, and then you would stop draining the tank at that time t equals k value. And that's it for part D. I hope this video was helpful to you. Stay healthy.